Borealis, often seen in northern latitudes, is one of the most awe-inspiring displays in nature. Charged particles originating from the Sun enter the Earth's magnetic field. There, the Lorentz force acts to trap some of these particles into spiral orbits around the pole due to the non-uniform shape of the Earth's magnetic field. When these particles wander near the poles, they often come low enough to collide with air molecules, causing them to emit visible light. Because these particles are charged, they can be thought of as a fluctuating current flowing into the atmosphere. By Ampere's law, this current creates a fluctuating magnetic field, albeit a weak one, at the ground. By Faraday's law, this changing magnetic field must induce an electric field. Although weak, when added up along a 1,000-mile power line, these electric fields can produce very large current surges, powerful enough to knock out a power station and otherwise interfere with electric devices.
Is like taking a trip down memory lane. The farther from Earth we look, the farther back in time we see. Starlight from the remote past is just arriving at Earth now. Telescopes are time machines for exploring what happened billions of years ago. But before the Hubble Space Telescope, we could only see so far.
We had a view that galaxies were out there a few billion years back, but we didn't know if they went all the way back to the very earliest epochs in the universe.
That all changed when Hubble got on the job. In 2003, astronomers used Hubble to look back in time to within 1 billion years after the Big Bang. This was the first time we were able to explore an age of the universe we could only dream of before. The image was called the ultra-deep field, and that changed everything.
We saw things that were much farther away than any previous observations had shown us, and also you're looking back when the universe was less than 1 billion years old and be able to find objects that existed at that time.
Liftoff of Space Shuttle Atlantis.
But when the Hubble was serviced for the last time in 2008, scientists saw a way to expand our vision of the universe even further by using the new infrared camera.
We could push out to earlier times. We could find even more distant objects than we'd ever been able to do before.
That new research,
Take the area around these objects,
combined with the ultra-deep field's use of visible light,
pulled out and displayed here,
is now called the extreme deep field.
We can't see the first galaxies, but this has put us on the fringes of that time. And so we've been sort of focusing in now on when the first galaxies formed.
As revealing as the extreme deep field is,
Then this one.
it's only a preview of what lies ahead.
We need to take a giant leap forward, and that's what James Webb Space Telescope will do. You know, it's 100 times what Hubble can do. So when that flies, you know, in minutes, hours, it can do what we've done on Hubble that have taken weeks, months. It's incredible.
What's also incredible is the realization that this small slice of the universe is just that, a slice. Multiply this by 30 million, and you get an idea of just how many galaxies are out there.
In daylight, our big blue marble is all land, oceans, and clouds. But the night is electric. Seen from space, our planet comes alive with light. This new view of the Earth's night lights is a composite of data acquired by the polar orbiting Suomi NPP satellite. Aboard the satellite, a newly designed instrument called VEERS is able to collect what scientists say is a remarkably detailed view of the Earth at night. In some places, city lights resemble solitary stars in the night sky. In other places, dense clusters of galaxies. The satellite can even distinguish brightly lit boats that line Egypt's Nile River, and the massive flames from gas flares produced as a byproduct of oil and gas exploration in the Middle East. As the satellite passes over the darkness of the Himalayas, it shows how human settlement is bound by natural borders. Even political borders are starkly visible in this view of North and South Korea, and in a line of fishing boats that dot the Yellow Sea. But not all light is electric. Glowing just as bright, flaming wildfires burn across Australia. This new view of the Earth at night offers a unique perspective for exploring the many places in which we live and seeing the impact of human populations around the world, no matter how faint or how bright their lights shine.